Good morning, guys, and welcome to today's video where we look at types of graphs. Okay, so this video it is a standalone lesson on types of graphs. Okay, so we're going to be looking at linear, quadratic, cubic, reciprocal, and also some tan graphs. Okay, right, guys, this video was recorded on Sunday the 29th of November 2020. Right, guys, this video is for GCSE, AQA, Edexcel, OCR, IGCSE, and WJEC. Okay, and then the next lesson will be a standalone lesson on modulus of functions. Okay, so that will be our plan for that, guys. Okay, right, guys. Okay, so if you're new to my channel, guys, welcome. My name is Abdallah W, and I'm a recently qualified maths teacher for secondary and primary. I'm currently doing walkthrough solutions to GCSE exam papers for Edexcel, AQA, and OCR. And if I get a chance, the IGCSE and WJEC at some point as well. Okay, so I'm doing walkthrough solutions to foundation and higher tier for GCSE, AQA, Edexcel, and OCR. Okay, if you find this video useful, guys, please do subscribe, drop the video a like, turn on the bell icon so you don't miss out on future videos. Okay, and also, obviously share my videos and spread the word, about my channel, and obviously, tell people about me and about my channel, if anyone find this useful. Right, guys, okay, without further ado, let's just get into the video. Right, guys, these are our learning objectives here for today's lesson. Looking at, recognizing what a linear graph looks like, recognizing quadratics, cubics, reciprocals, and also some trig graphs. Okay, so trig graphs, okay, so sine, cos, okay, graphs, okay. Right, guys, okay, so check out cobbitmaths.com or mathswatch .co.uk for more worksheets and revision worksheets. Okay, so Cobb Maths is brilliant for like loads of like worksheets, okay, for GCSE and also primary level maths as well. Okay, and also Key Stage 3 level maths as well. Okay, because there is like a lot of overlap between Key Stage 3 and GCSE maths. Right, guys, linear graphs. Okay, so linear graphs are in the form y equals mx plus c. So it's got a power of 1 here. So linear just means obviously power of 1. So a straight line graph actually, so a linear graph actually is a straight line graph that looks something like this actually, okay? So if the gradient actually, so m is the gradient and c is the y-intercept. Okay, so m is the gradient and c is the y-intercept, where it crosses on the y-axis. So that's my plus c. And this is what I call a positive gradient. So if and only if m is bigger than 0, then it looks like that. If it's negative, then it looks something like that. Okay, so that is if m is less than 0. Okay, so if it's negative, so that's my slope that way, and that's my slope if it's positive. Okay. So that is like a general overview. Okay, I have done a full video of this back in March and also in February this year about how to plot graphs. Okay, so please go and check out that those videos back in early March, end of February. Earlier on this year. Okay, back in February, March 2020. Right, guys. Okay, so that is like a little overview. So that is what a straight line graph looks like. So these are what I call linear graphs. So it's straight line graphs. Okay. This is also so a horizontal line and a vertical line are also linear graphs. Okay, that is when the gradient is 0. Okay, so that is so m is equal to 0 for these. Okay, so when m is 0, okay, the graphs are either horizontal or vertical. Okay, so that is when m is 0. Okay. So vertical lines is x equals a, and horizontal lines are y equals so y equals b, and x equals a for for vertical lines. Okay. So I hope that actually made sense, guys. Okay, any questions or queries, put it in the comment section. Right, guys, quadratic graphs. Okay, so quadratic have what we call like an x squared term. So it is in the form of y equals ax squared plus bx plus c. So they are normally like u-shaped. So a quadratic normally looks something like this. Okay, so that is what a quadratic looks like. The plus c is where it crosses on the y-axis. Okay, and then the a and b just obviously determine how steep the graph is. Okay, so that's a positive when A is positive, and when A is negative, okay, it is a N shape. Okay, so it looks something like this. Okay, so that is what I call a negative quadratic. So A is less than 0, okay? So a positive quadratic is a U-shaped, a negative quadratic is a N-shaped, okay? And yeah, so where it crosses on the y-axis, that is going to be the plus C, okay? And a few other points to mention, guys. So where the quadratic crosses on the x-axis, that is when you solve the equation. So where it crosses on the x-axis, that is when y is equal to 0, okay? So when the graph crosses the x-axis, okay, that is when y is equal to 0, okay? So I've seen like a lot of questions on past papers where it says solve the equation ax squared plus bx plus c equals 0. Yeah, basically what it's saying is where does it cross on the x-axis? So when y is equal to 0, okay, that is the x-axis, okay? And then similarly, when obviously when x equals 0, that is your y-axis. Okay, so this is like a little overview, guys. Okay, I have done a video on this as well back in, I think it was November last year. So yeah, November or December last year. So check out my video, or it was in January this year. Okay, so check it out, guys. Right, guys, okay, so cubic graphs. Okay, so cubic graphs have what we call like an x cubed in it. So cubic graphs are in the form of y equals ax cubed plus bx squared plus cx plus d. Okay, they are in the formula of this. Okay, so it looks something like this normally. Okay, so that is what a positive. So when a is bigger than 0, sorry about my handwriting, guys. That should be an A, not a D. Okay, when a is bigger than 0. And then obviously when it's obviously negative, then it looks like this. Okay, so when a is less than 0, then the graph looks like this. Okay, so that is obviously my sketch. Okay, so it's like an S shaped. Okay, so it's like a like a side S. Okay, for a cubic. Okay, remember also, guys, oh yeah, I forgot to mention actually, so quadratics always have 2 solutions, cubics have 3 solutions, but for the purpose of GCSE actually, you will normally be told what the roots are, of your equation. Okay, so sometimes this topic might link to like expanding triple brackets, because triple brackets are essentially cubics, okay? But again, where the graph crosses on the x-axis, that is when the solution, that is when y is equal to 0, when it crosses the x-axis. And the plus d just means where it crosses on the y-axis. Okay, so I hope that actually made sense so far. Okay, so the plus d is where it crosses, sorry. God, it's poor drawing today. Apologies about that. Sorry. So where it crosses on the ever, so that's going to be my plus D. Okay, the A, B, and C just obviously determine how steep or like shallow my curve is. Okay, so obviously the bigger A, B, and C are, the more steeper that the graph will be, if that makes sense. Okay, so that is obviously cubics. So cubics have 3 solutions, okay, and quadratics have 2 solutions, okay? And then obviously power of 4 is obviously what we call quintics, but we will not worry about quintics here for our video, okay? But power of 4 has obviously 4 roots, and sorry, a quartic is power of 4, which is 4 roots, and then a quintic is power of 5, which is obviously 5 roots, okay? But so whatever the number on top here, that is the number of solutions the equation has, okay? But for our purposes, you will not be required to obviously know how to actually factorize a cubic, because that is more for like AS level maths and A level maths. But if you're interested, feel free to like check out some A-level videos here, either on my channel or I think on Tube Majid's channel or TR Maths Jack Brown. Okay, if you are interested on how to factorize and solve cubic equations, and cubic, and being able to plot cubic functions. But for our purpose, for GCSE, we're just looking at what the shape of the graph looks like, because I've seen this appear like a lot on exams. Okay, right guys, last 2 slides ever. Okay, so reciprocal graphs, okay, so they are in the form actually y equals k over x, okay? So reciprocal graphs look something like this, okay? So that these are what I call a reciprocal graph. Okay, now it looks like this, guys, here, for like one of 2 reasons. Firstly, as x gets smaller and smaller, okay, y gets bigger and bigger. Obviously, x can never equal 0 because we can't ever divide by 0. So x can never equal 0 for these equations. Because we can't solve yet that. Similarly, y can never equal 0 either for our purpose. Because as y gets bigger and bigger, x gets smaller and small. Sorry, as y gets bigger and bigger, x gets smaller and smaller. Yeah, if that makes sense. And as y gets bigger and bigger, x gets smaller. Okay, so I'll put like a little notation here. So as x tends towards infinity, okay, so it gets bigger and bigger, y gets closer and closer to 0, but it never ever touches 0, because this is what we call the asymptotes. Okay, so so it never ever touches these lines. Okay, and then finally, minus k over x again looks something like this. Okay, so minus k over x looks something like that. Okay, so that is y equals minus k over x, where k is just a constant. Okay, so k is what we call a integer. Okay, so k is a constant. Okay, yeah, integer just means whole number. Okay, so that is what a reciprocal graph looks like. So don't worry again actually about that. But the key point to remember is obviously x can never equal 0, and nor can y, because we firstly cannot ever divide by 0. Okay, for x and for y, there are no 2 numbers that divide to make 0. Okay, if that makes sense. Okay, so these axes are what I call asymptotes. Okay, so that is like a little word actually. So asymptotes. Okay, so these lines are what I call asymptotes. Okay, so asymptotes. Okay, so these lines, okay, so the x and y axis are what we call asymptotes. So the curve gets closer and closer to the x and y axes, okay, but it never ever touches or crosses them because of that whole reasoning that x and y can't be equal to 0. Okay, right, okay, lastly, okay, so some trig graphs. Okay, so this is what a sine graph looks like. Oh, sorry. And this is what a cos graph looks like. So bear in mind, guys, that obviously sine, yeah, it starts from 0. So sine has a period of 360 is what we say. So it has a period of 360. And what that means is that the graph repeats every 360 degrees. Okay, so it repeats every 360. And similarly for cosine, there is a period of 360. Okay, so that is my answer there, guys. Okay, so they are my graphs. Okay, so make sure that you're happy with how to plot them. I have done a video on this again back in January, February, I believe actually, and also in December, for how to plot sine, cos, and tan. But make sure that you are happy with how to plot them, how to sketch them, and obviously memorize them. Yeah, obviously feel free, yeah, to obviously take screenshots of this video, yeah, and obviously copy down this graph if needs be. Okay, but that's what a sine graph looks like, and that's what a cosine graph looks like. Okay, so that is out there, and then obviously a tan graph looks something like this. Okay, so a tan graph